Guys, I want you to give yourselves a big pat on the back because you enabled my hoarding habits. You guys made me go out and buy a few more astronomy books. Not as old as this guy. And by the way, for those of you guys cringing at the little flap here falling off, don't worry, I got some special non-acidic glue to piece it back together. We're gonna maybe make that into its own video, trying to repair that book. You guys loved the astronomy book, and that was really cool because I enjoy buying books, used books preferably, actually. And today I got my buddies Tomato Leaf and Pumpkin Spice here with me. We're gonna pop up on the shelf. It sounded more interesting in my head, but I do like candles, so we're gonna light these real quick. But today's video is gonna be us sort of unboxing. I already opened them up, actually. I just kept the packaging and put them back in. We're gonna give you guys a rundown of my new astronomy books and my dozen or so older already purchased books I've had about astronomy and space. I won't say astronomy per se, because I have a book like this on rocketry and about space travel. All of these are books that I eventually want to kind of use to make independent episodes about, but well, it'd actually be a shame to me I didn't trim these wicks, so they're gonna be nice and poppy. Poppy. That'd be a thumbnail if I wasn't making this video on astronomy. You know what, and briefly, since I just realized I'm wearing a wedding ring, I might as well tell you guys, I got married. Most of you are gonna know Molly. I haven't had her on the video proper, I guess, in a while, but any of you guys who follow my IG know I had a girlfriend, then I had a fiance, and now I have a wife, which is so interesting to say. Oh my god. And now I got a dog dropping farts on me right under my desk. Oh my god. Ernie. Oh my god. Oh my. You stay out in the hallway. You stay out. Yeah. You're dropping farts on me, buddy. You're dropping atomic farts. You're blasting me away. That's ridiculous. So, anyways, now that Ernie's singed my nose hairs off with his volatile farts, he's got bad gas. I don't know what to do about that. I need to change his diet, maybe. But yeah, I'm married, and I can say 2 weeks into it, and I'm happily so. I'm a lucky man, very lucky. And if I didn't love her enough, if I didn't have a million reasons to love her already, she picked out that date because July 20th is the day that Neil Armstrong and Buzz Aldrin and Michael Collins, I think it is, landed on the moon. And it's the day he put the first human footprint in the moon's soil and said it's one giant leap for mankind. And I thought that was pretty symbolic too. That means a lot to me, and she knew that, and that's why I'm the luckiest man in the world. So anyways, that's some very cool news. that I've had recently in my life. Big steps. Making big steps. For those of you who cared, who have, been following my life changes throughout the channel in the past couple years. Alright, the first book that you guys, in my newly reignited love of buying used books that you guys kind of enable, I'm going to blame you guys for this vice of mine to just procrastinate and waste hours searching for used books online. I got this one off eBay. And the more, again, it's hard for me to make this kind of an improvisational, impromptu video because every topic I get into, I find that there's so much, especially with the internet nowadays, we can go down so many rabbit holes, and there's a lot of deep rabbit holes out there, even non-conspiratorial ones. So as I'm getting into the Drake equation, and which is essentially just a very educated guess by an astronomer of the likelihood of intelligent civilizations that are not only exist but are actively communicating, propagating some form of most likely radio wave communications. Although I shouldn't say most likely, we'll talk about that when I do eventually make the video. But he comes up with 8 or so variables that you can tweak, you can tune to get different results in the end probability, the final result, I guess. And that lumps him with SETI, the search for extraterrestrial intelligence. And yeah, I purchased all these books to learn more about the science of astronomy, what we know in general about space and our place in it. And I just realized I'm bumping this table. Hopefully that's a little better. Okay, secure. But looking through, this old 1800s book just really piqued my interest as far as finding out what we know. It made me want to know more about this, technological, scientific, revolutionary time that we're in. And I fused today with the last 150, 200 years even, actually, as a remarkable novel era in human achievement and evolution in general. And it's, fundamentally it's me wanting to know more about our universe, but about our place in the history of humankind. And the more I understand about astronomy, which I guess I'll just get to unpacking this, the more respect I have and awe I have, it fills me with, in regards to just how much we're learning about space and our place in space and time. So I'm kind of on an oddly parallel journey right now in my self-education, which you guys again are a huge part of, just because you support me, and I wouldn't have time to learn all this stuff if it wasn't for you guys encouraging me and watching and giving me feedback, and all the financial support on Patreon, by the way. Let me segue into that real quick, because I don't say it enough, in all honesty. So all of you guys who support me on there, and just in general show love on the channel, I had to plug that real quick and then show you guys my gratitude. honestly. So, the point of all these books I'm about to show you today is, you know, they're purchased in pursuit of a deeper understanding and a broader understanding of our place in history and where we might be going. And the more I learn about it, the more I really, really think that there is a very high probability that within the next 100 or so years, our radio communications will let another intelligent civilization be cluing in another intelligent civilization within, 20 to 100 light years from us on some distant, or I should say locally, cosmically, a very local distance, would be a couple tens of light years from our solar system. So anyways, I really think, we're not only going through our own earthly, technological, moral, scientific and spiritual revivals and evolutions, but also I think cosmically we're at a new precipice that we've never been at before, and in a very quickening, at a very accelerating pace too. So I just want to know what we know, because I feel like even the most basic stuff, and I'm so glad that you guys enjoyed the a lot of my astronomy based videos, but the basics of astronomy in particular, that's kind of what I want to do. I actually bought, you can kind of make it out back there, I bought like a little kid's size easel with a chalkboard on one side and a dry erase board on another to set up, and hopefully it's not too cheap. I got it at Walmart, but to kind of, make it more interactive and write equations and get into the physics of astronomy more often, because I'd really like to. So as I educate myself, purchasing books about history and just general information about astronomy in particular. This one is called The Search, Cosmic Discovery, The Search, Scope, and Heritage of Astronomy. You can see none of these books are really new. I bought one textbook that was from, I think, 2006, and even that is, somewhat dated in certain areas. But this book is just a nice overview, to kind of get my feet wet into it. So this is, this book's written by, let's see, when was it written? Let's see. It's written by Martin Harwood in born in 1931. I'm assuming this guy's passed away by now. This book is from 1981, so this guy wrote it when he was 50 years old. And he was born in Prague, Czechoslovakia. He was a professor of astronomy at Cornell University, so that was Carl Sagan's university. So a part of me jumps to the probability that he was encouraged by Carl Sagan to write his own book, Search, Scope, and Heritage of Astronomy. I like this because it's not a dry textbook. It includes, I'd say, some elevated mathematics and physics concepts in it, but overall its appeal to me is that it's takes on a more conversational tone and a more just a more poetic style rather than dry prose of most textbooks. It says cosmic discovery in the first page here is an investigation into the complexity of the universe. It's addressed to a wide range of readers interested in astronomical discovery from the astronomers, the historians, and policymakers' points of view. I've tried to avoid the specialized jargon of each of these three fields and have appended a glossary to explain those technical and lesser known terms and abbreviations that had to be included. And yeah, really the overview of this book in particular is that it contains, let you guys look at that, contains the, I guess I can't really manage that one. First, it contains 5 chapters. First one summarizes the most important findings and conclusions of the study of astronomy. Readers mostly interested in ideas and results rather than the substantiation and evidence in the process may find themselves satisfied by this chapter-length essay. Others, particularly professionals, more interested in a thorough examination of the subject, will find full documentation in the remaining 4 chapters. So, I just really enjoyed this book. It popped out, and again, these books are cheap, because astronomy is a constantly evolving subject. When one section of one chapter gets outdated, it's profitable, especially in the universities with textbooks. Unfortunately, they sadly price gouge those textbooks and put that financial burden on the students acquiring debt, which is incredible that they do that. But these books are cheap. This book is 40 years old, but I would probably say 90% of it, 95% of it, the overwhelming majority of it is still very relevant and accurate information. So, yeah, he just goes into discoveries, major breakthroughs and discoveries. This is like I need to read this first chapter, which I haven't even done yet. It's just a great overview of all the discoveries. He even has a graph. You know what? Maybe I should I think I was gonna do an introduction like I did with my introduction to astronomy video, or basics of astronomy video. Face the camera and then just transition into looking down. So yeah, I think I'll do that right now, and we'll get into all these books, because I want to show you there's a couple graphs and all that in this book. So, commence transition. So I just looked up Martin Harwood. He's still alive and kicking at 89 years old. Born March 9th, 1931. So, good for that guy. This guy right here. I just wanted to show you guys this cool chapter. This graph in the first chapter, So it says stars, planets, novae, comets. we got moons, planets, everything before, 1600, which is roughly a good date to call the dawn of the modern era of science, modernism, technology. It didn't really get into full swing, it didn't pick up steam, so to speak, until the 1800s. But, the polishing of lenses for Galileo to be able to look up and see the moons at the beginning of the 1600s. You could see moons and rings of Saturn and Jupiter. Or the moons of Jupiter, rings of Saturn, I should say. And, basic mechanistic things like clocks, which is why we have a huge analogy back in those texts of a clockwork universe. And then we have galactic clusters. Let's see, 7, a little bit after 1750. Let's see, 6, those rings. 1650. Yeah, I guess so. Rings weren't exactly made out. Saturn just looked like it kind of a sphere with two big ears coming off it. The gap between the rings and the planet of Saturn wasn't able to be truly discerned until about 60 or so years after Galileo had already been looking at it through his telescope. But then we go into the 1800s. That's when our old book, early 1800s, that's when it started to be written. Was it from 1836? I think it was. So, right before that book, we had 7, 8, 9, 10, and 11. Galactic clusters, clusters of galaxies, interplanetary matter, and asteroids. All of which we didn't know all the characteristics of, but we knew that we were at least able to spot them for further future observation. And let's see what else. Right before 1900, we have variable stars with nebulosity, which I guess means indications of gaseousness around them, maybe like in the planetary nebulae, which maybe that's kind of what we thought. It was a star and it looked like it had a ring, looked like it was sitting within a nebula. Globular clusters, which we now know are satellite galaxies, clusters of, tens of thousands of stars that themselves were kind of created independent of our own galaxy, but perhaps were young proto-galaxies that got absorbed into our galaxies and now kind of orbit around the outskirts of our galaxy. And then anyways, it's cool how you see and I'm not sure what the exponential curve, I guess, what I was getting at, of discoveries here. And these are all very massive discoveries. These aren't, X-rays, X-ray background, microwave background. That's the indication that of the universe's characteristics at its infant, at the earliest stages that we can determine, I guess, 15 billion years ago, when we think things hadn't yet coalesced into galaxies and stars, but they were kind of this hot soup of very elementary particles, bubbling over with heat and energy, just hundreds of, for the first, a few 100,000 years after the Big Bang. As far as we know, we don't know what really happened before that, but everything we know about the Big Bang, we kind of extrapolate based on that. Infrared stars. So, these are major discoveries that are cluing us into the nature of stars, and as we can detect all the... I hate when books I have to open them up like that. It's like an impulse I have. But it tells us, once we discovered the electromagnetic spectrum, which I'm sure we have a graph of that somewhere. Wavelength. Yeah, here we go. So, smaller wavelengths, as we discovered that light was just one part of this dynamic interaction, this interweaving of electromagnetism, electric energy and magnetic energy, an oscillation of these two separate fields that are perpendicular to one another. So electricity is undulating like that, and magnetism's undulating like that, traveling in conjunction with each other, but exactly at a 90-degree angle to each other, which I really don't know what that means, honestly. I've done math describing that, and I've learned the equations in school, but the actual nature, what that actually means, is so elusive. It's so interesting. But we know so much more about the nature of the universe now that we're able to probe it across all these different wavelengths. So we got electromagnetic radiation, cosmic rays, solid bodies, neutrinos, gravitational waves. Table 1.1. Man, yeah, this book is so amazing. We already got some I enjoy, as long as it's not overly annotated. I enjoy looking at other people's notes. And you have a new respect for the information that we know, because as kids, astronomy is one of the more glamorous sciences, because it's so easy to, point the camera in the sky, and you have these grand pictures from the Hubble telescope. And so it's easy to, we're so flooded and saturated with those images. It's easy to just kind of take them for granted, I think. But there's so much intensive thought and labor, mental labor, and genius, logical analysis, I guess, that goes into understanding, so much mathematics, so many bright ideas that go into understanding in unveiling the nature of the universe. Fundamentally, a lot of sciences are discussions of information, like DNA is such a breakthrough in the field of biology because it's a transmitter of genetic information, or it contains, in a very simple way, information that creates an incredibly, unrealistically, almost unfathomably complex organism out of these 4 simple molecules and just different patterns in different organizations of these molecules. And the same goes, for this, physics and chemistry and astronomy. And we have 5 known types of carrier that transport information across the universe. One is electromagnetic radiation. That's all these right here. So in this chart is, let's see, our atmosphere is a good filter of a lot of these types, a lot of these frequencies of electromagnetic radiation. So you see here, it's all open on the ground. So microwaves and radio waves, the 2 largest, lowest frequency types of electromagnetic waves, actually penetrate the atmosphere. But these, as do some area of gamma rays. And this is right here. This is about our invisible wavelength here. Oh, sorry, right here. Yeah, this is in nanometers right here. I think they got the scale kind of off. Visible should be... Oh, no, that's right, because it's more like micrometers, I guess. Yeah. So we have, interestingly, this very narrow band of the EM spectrum right here that penetrates the atmosphere. And when we go outside, our thick, very thick atmosphere relative to the moon and Mars and Mercury, not as thick relative to Venus and all the other gas giants, of course. But we, we're adapted to navigate in the visible spectrum, the visible range of the electromagnetic spectrum, EM spectrum. And we're spared the exposure of to all the radiation in the much, much smaller wavelength, higher frequency range of the EM spectrum. And radio waves right there, as far as, transmitting information. We think that Drake and a lot of these other people, Carl Sagan included, being one of them, and I got his book Cosmos here we're going to look at. They propose, for a very interesting reason, a very thoughtful reason of, just very logical reasons, that we would most likely receive transmissions from extraterrestrial intelligent technological civilizations in the radio wave area of the EM spectrum, because without going into too much of the science, even though I don't know much of it, hydrogen is the simplest molecule, simplest atom, the atom with the fewest number of protons in its nucleus. It has one proton in its nucleus. I'm sure there's a periodic table back here. Temperatures in the universe. But because it's the simplest, it's also the most abundant, because it takes the fewest number of, the fewest energy, the smallest energy, and the fewest number of, it's the most stable, I think. I want to say it's the most stable. I think so. But in the order of complexity, it's the least complex atom, one of the most stable, and the most abundant in the universe. And it, like all atoms, give off a photon of energy in the certain, which is essentially a unit of energy in a particular wavelength. Let's see. Yeah, I guess they don't have it. I know the textbook will, though. So let me keep it rolling, I guess, and continue my train of thought. They give off when atoms absorb or emit energy, they do so at a particular wavelength that corresponds to their size and their own kind of intrinsic relationship between their nucleus and their electrons. And electrons kind of, I guess you say occupy. You don't really say hover. You don't really use words of conveying motion, because it's kind of like this static field that just surrounds a nucleus. And here's a good example. But anyways, when they shift the electrons, here we go. When we bombard atoms with energy, their electrons absorb some of that energy in specific amounts, kind of like finite units that can't be halved or fractionated in any way. So they do it in multiples of units of energy called quanta, and they get stimulated to a higher energy state when they get hit with energy. And then I think hydrogen, after something like 12 million years or something like that, eventually what's the word? Suddenly, almost, one day, 12 million years later, release that energy, and they move back down to their ground state. The electrons do, a little bit closer, if you will, I guess, orbiting the proton. And that's all the hydrogen atom is: one proton, one electron. And when it does drop back down to that energy state, it gives off, essentially satisfies that equation. It absorbs some energy, hung on to it for 12 million years, and then released it, that same amount of energy, in the form of a proton. And we recognize the spectral lines. It does that it gives off that energy at a specific wavelength, and we can detect that using specialized instruments called a spectroscope, where we can separate light into all the different wavelengths it's made up of. And anyways, Drake and these guys called Cocconi and Morrison figured that because hydrogen is the most abundant element in the universe, the pioneers, one of the first, it would be one of the first targets of telescopes, spectroscopes, instruments looking into the universe for more information. And so they think that civilizations that are advanced in trying to reach out and communicate to other upcoming civilizations would communicate in this wavelength that they know the original civilizations, the emerging intelligent civilizations would be probing the universe for. They know that, and of course they're basing all this off of human history, so they have evidence that that's what we did. We probed, for hundreds of years, we probed around and discovered that hydrogen emits photons at a certain wavelength. We could see that, and we could see that it was the most abundant everywhere. And they think that essentially we'd be looking, because we'd what am I trying to say? Essentially because young civilizations would already be most likely to be looking in that area of the wavelength spectrum. They think that would be a good frequency to communicate at. Cosmic ray particles is number 2. So we have so as I've been researching this Drake equation and SETI's general findings and what they're exploring, it's definitely piqued my interest that the reasoning has impressed me quite a bit, and it's helped, inform my take, and I hope it will yours once I get this video pieced together. Understanding of the probabilities and likelihoods of how many civilizations there are out there, and I think there are, I think the data that we have currently, at least, shows that there are quite a few. Maybe, if not thousands, at least tens in the Milky Way, which would make uniformly distributed, roughly, some within 1,000 light years of us, given that the Milky Way is 200,000 light years across. And yeah, the restrictions that we logically put on which wavelengths we probe the universe for communications with are interesting. That we think it might be too it would be too expensive to be shooting off a spherical set of high intensity energy waves. They'd have to be too narrow. They're angular. What's the phrase there? Anyways, their angle that they're dispersed off, their angular arc or whatever, is way too narrow. It would have to be directed at exactly at our sun, and they might have that, but one of the rationale for searching in the hydrogen wavelength was its ability to probe life-giving atmospheres such as ours. So they want something that would fit within these ranges. So it could be visible, could be optical, They think most likely it would be in the microwave or radio wave wavelength because these travel the furthest for the fewest units of input energy, and then it could be way up here in the gamma ray scale, where it would be able to penetrate atmospheres, but it would be very energy costly. Very, very costly. So for a Kardashev, anything registering more than 1 on the Kardashev scale, being able to harness, 1 being a civilization able to harness their full power of the planet that they're on. I think 2 being the entire sun that they orbit, and then 3 would be either galactic or at least interstellar, meaning they'd be able to live across multiple stars and, proportionately be able to harness the power of multiple stars that they inhabit. And then 4, I think, was galactic, which I think we'd know, or maybe not. I mean, again, it's like every door opens up 2 more doors. It's like, in a way, his reasoning is interesting, and I guess I won't dwell too much further on this, because I do want to, discuss it on the video proper, but, it's just really interesting that, maybe civilizations are casting just a wide net and using the least, the most energy efficient and, I guess, crude medium through which to transmit energy and messages and information, fundamentally, could be the radio waves. But then, that's also a one-way communication, which leaves them vulnerable to being essentially voyeured. Their awareness, their existence is now known without any reciprocation. So, in a way, that's kind of a foolish thing. I think Stephen Hawking or one of the popular astrophysicists, astronomers, said that it's kind of like yelling out in the jungle at night, giving away your location to predators. You could find another human that might help you cooperate to survive in the jungle and flourish, or you could be inviting predators to know your location at a minimal risk to them, So, and even beyond the predator-prey lens, we might think that, a part of me thinks, from the little bit that I understand about this, maybe there is a litmus test, a kind of shibboleth that an advanced civilization might want to, use in order to vet the potential civilization's onboarding into the galactic, community. So, in other words, maybe they might choose the more high energy, more intensive route. And someone sufficiently advanced, again, we've come a long way in just 200 years. Imagine 2,000 years, or God willing, 1,000,000 years of further technological innovation for us. And we can, the discoveries that we might make these forms of information carrying either obsolete or just very superficial in terms of how we understand how an advanced civilization might understand how the universe works. So maybe electromagnetic radiation is, if we analogize it to like a caveman, to us, it might be sharpening a stone, spear flints. And then much more advanced civilizations, like as we invented the wheel and the lever and the pulley, and then lenses, and then we discovered electricity, and then we were eventually able to probe the atom for nuclear power. Maybe that is a more sophisticated area in which that they might communicate using gravitational waves, neutrinos, antineutrinos, particles that we are, just beginning to discover in the last 50, 60 years using particle colliders. Everything we know really exists on the visible wavelengths, solid bodies. So it was really just massive particles. We have, matter. Like everything we can see. We have chemical energy. We have visible wavelengths. And then there's way more fundamental particles. Let's see. Cosmic ray particles, highly energetic electrons, protons, heavier nuclei. Possibly antimatter. Neutrinos. And again, this book is 40 years old, so I think a lot of this is going to be dated technologically as far as what we've detected. Gravitational waves theoretically predicted radiation from rapidly accelerating massive bodies such as exploding stars or binary black holes orbiting each other with so much mass and output of energy that they actually propagate undulations in the fabric of gravity that would be detected. I think we've detected those, but anyways, I feel like I've just spent an hour on this one book, and I have like over a dozen books, so I'll probably edit this one down a bit. The last little bit of this chapter is interesting, that he is speculating on not what we know, but what we can know. Which in a way is like metaphysical. So, he's speculating on, based on discoveries to date. In this one section, he just points out 1960 to 1979, noting that there's been 9 massive, major, revolutionary discoveries of new phenomena in the universe. X-ray stars, a background quasars, X-ray galaxies, so being able to look at galaxies through a filtered lens of not just visible light, but different types of light, and X-rays being some of the higher energy, I guess soft and hard. There's, different levels within the spectrum, within the levels of the spectrum. X-ray is second only to gamma rays as far as how intense its energy is, how short its wavelength, how high its frequency is. We have gamma ray bursts, unidentified radio sources, which SS43, apparently a new phenomenon. Actually, look at that. And then there's one last one he says. It's called SS43, assigned to the observed source, appeared. Let's see what that is. SS433. What is that? SS433 says one of the most exotic star systems observed. Let's bring this in the frame here. It says one of the most exotic star systems observed. It's an eclipsing X-ray binary system, with the primary most likely a black hole and possibly a neutron star. The spectrum of the secondary companion star suggests that it's likely a A-type star. A-type. Microquasar is the first discovered microquasar. It's at the center of the supernova remnant, W50. Wow, look at that. Okay, very interesting. Look at that. What? That's cool. Look at that, would you? Look at it. Most likely, W50 and SS433 are related objects, remnants from a supernova which occurred about 20,000 years ago. Interesting. 18,000 light years away. So that would mean we saw it in the sky about 2,000 years ago. Lines up with Christ, isn't that interesting? If I were prone to speculate about those types of things, which part of me is, I might really run with that. Anyways, that unknown radio source aside, is this guy thinks that by the year 2200, yeah, I guess that's what we'd say. By the year 2200, 180 years from now, he thinks, we will have discovered, by the year 2200, we should become aware of some 90% of all multimodal phenomena characterizing the universe. And I'm not sure what he means by that, but I don't want to read it right now. So. And he notes also in another section the declining funding for cosmic exploration. So obviously he's a fan of funding departments in areas of research pertaining to cosmic discoveries. proposing at the end here an outlook. Some guidelines along which it should not be long before we approach the end of mankind's most exhilarating era, the epic of cosmic discovery. Anyways, that's Martin Harwood's book. And I like it because this is kind of like, it's almost like he's the Will Durant of astronomy here. He's putting everything that we know so far, and obviously he's an astronomer himself, part of the member of the Max Planck Institute, Cornell. Wrote another book, plenty of articles, holds a number of patents for technical innovations. This guy's a polymath. I love it. And it's men like this, men and women like this, that I think further inspire new generations of people to continue exploring, because they aren't afraid to creatively speculate where we're going, and they're not just trapped in maintaining the dogma of currently accepted information about the world. You know, they're on the edge of probing the periphery, you know, the boundaries of what we know. And that's awesome. That's fundamentally what makes us human. Very cool. Very inspiring. So I want to learn more about astronomy through that. Next up, these next two books are equally useful for me, I think. This one was more of an artistic book, 1,000 Years of the Art and Science of Astronomy. Okay. And I really got this one because of its pictures. Another line of inquiry that I'm navigating is the divergence of alchemy, essentially spirituality, and the condensation of a factual scientific worldview out of kind of a filtering of the facts from the pre-scientific, spiritually, religiously charged, infused, saturated worldview that all our ancestors came out of. This guy here, this guy, for instance, was writing in 1638, 400 years ago. He was speculating about life on the moon, other places. Bernard Fontenelle wryly noted that all philosophy is based on two things only: curiosity and poor eyesight. So, let me make sure I got a good view here. it's really cool to, I think it's encouraging. It literally gives me courage to discuss and pursue these ventures, the things I do, like the Drake equation. It can be dismissed as too radical and too unrealistic, but I really don't think it is. If we think about just how much is out there, how many worlds, how many stars, and just how likely it is that there might be so many inhabitable at least, stars, planets around stars that have an enduring lifespan of, billions of years, very stable, middle of the road, average sized, average energy output stars that would encourage life to form around them. I think there's so much information indicating that there is probably a lot of life teeming, the universe teeming with life out there, and it's cool. It's cool. It really makes you feel a part. It's meaningful. It makes you feel a part of a bigger story, much bigger than your own life. And in a way, that's the most we can all hope for in life, is to partake and participate and be a part of not only our family, but our community in the voyages and adventures we go on independently, individually, and as a community, and ultimately as a species, And I feel a kinship with these guys, speculating in 1638, the first two printed works on the possibility of travel to other worlds in life on those planets were both published in England in 1638. First of these, although given less credit as an early work on extraterrestrial life and travel, had a number of progressive ideas. So we got Francis Godwin, 1552, born in 1552, student at Oxford in 83. He had been influenced by ideas propounded by Giordano Bruno. Wrote a literary work of fantasy entitled The Man in the Moon. Moon with an E there. Or a discourse of a voyage thither. And Bruno's works included a book entitled On the Infinite Universe and Worlds, which proposed that all the planets of the solar system were, like the Earth, inhabited. The idea that travel to other worlds and the possibilities of life there wasn't entirely new. Galileo, Descartes, and Kepler had all cautiously recognized the possibility of extraterrestrial life. His ideas were extraordinarily progressive for a 17th century literary figure who was not technically or scientifically trained. Wow, look at that. His romance is filled with conceptions of gravity and weightlessness, and hints of the helicopter, nuclear power, reverse thrust, and non-human, meaning robotic, meaning robotic, human, non-human payloads. Ideas that have evolved in the modern phase of aeronautics. God, it's cool. It's like, who isn't inspired by that? It's amazing. That's amazing. It's and it's so positive too. It's there's a phrase that the first inklings of great scientific achievements in discoveries and advancements and leaps are first found in poetry and fiction. And it's true. How many people are just, in a real way, how many engineers that invented cell phones or helped integrally design their look, especially with the flip phone, were influenced by Star Trek in their flip, what do you call them? Transponders? Tricorders? You look at Star Trek, The Next Generation, in the 90s, early 90s, they had their panels looked like touchscreen iPads. No doubt Steve Jobs was inspired to create the iPhone and the iPad. Which I watched an interview of him in a couple years, maybe 2010 or something, after the iPhone had come out, and he actually said that the iPhone was originally second to the iPad. He had originally invented the iPad, or came up with the idea, conceived of his first touchscreen device at Apple being an iPad. And only later they had to minimize it and came up with the idea of making a cell phone, which I even heard the other day someone talking about pre-iPhone. It really is one of those great technological inventions. We all take touchscreen technology for granted nowadays, but it was revolutionary when he invented it, for sure. So anyways, this book, very visually interesting. Look at this. From 1750, Thomas Wright, titled An Original Theory or New Hypothesis of the Universe. Wright's vision of the infinite number of universes that may exist, which he called a finite view of infinity. Look at that. These are all views outside the spheres upon which many thought the stars were imprinted. And whether who knows how far off he actually was there. And here we got very atomic looking views. Again, another 1750. This is Wright's view of nearby star systems. We have A, B, C. So A is ours, B is the star system around Sirius, C is star system around Rigel. Here's a picture drawn by Isaac Newton in 1687. This is a diagram showing the locations and appearances of the comet of 1680, later known as Halley's Comet, in its parabolic orbit around the Sun. And you see the tail of the comet is changing. Its angular location is deflected perfectly away from the Sun. So the Sun's wind, solar wind, the particles it emits, is blowing the exposed, elements and chemicals and dust off of the comet's surface, blowing it behind the comet. So this whole book is, we'll probably go in much more detail, but, on top of it being just interesting visually, I mean, who didn't like looking at those pictures of the star systems? I think it's also very informative historically. It's very educational about where even the most speculative thinkers were in respect to the truth that we currently hold, at least. So, and here is a great example of the monumental efforts that went into observing the stars that, we take for granted now. We got machines to just follow and track stars, and we have images, and they didn't even have photographic plates until the 1800s. So they had to draw what they were looking at. They couldn't take a picture and then go back and analyze it. Or nowadays, record, terabytes of data and then have, thousands of lines of code, post-process it, and decipher, filter out elements that we're looking for in particular. They had to track it, keep numbers, use these instruments like the one we just saw, these sextants. This is one of Tycho Brahe's right here, measuring the distance between celestial objects. You have massive angular sextants to make, to try to measure parallaxes. Rene Descartes. And look at that. That's recognizing that human anatomy of light, how it enters the eye lens and how it hits the back. So we must be seeing the world upside down. And apparently that's true. We somehow, I wonder if babies view the world upside down, and then just by sheer necessity we all have to, psychologically I guess, mentally, unconsciously though, flip the image right side up. So, alright, and then we got Hubble and more modern views. All beautiful, awe-inspiring pictures. And again, I got this book for cheap. This was like $4 or something, $5. I don't know. Or maybe this one was a little more, because these, with the high quality images, are usually a little more expensive, but it was worth it. Maybe $10, So the last book I recently got, and you know, maybe I'll make this its own self-contained video, and we'll go into the books I've had longer, at least, in another video. But this book here is a textbook, Explorations in Introduction to Astronomy, by Thomas Arney, 4th edition. Sure, it's probably like $100. Who knows? Maybe $200. Which, you know, I understand a lot of work goes into this, but I just think it's a sin against the youth, make them pay so much for books. But this one was written in 2006, originally 1996, in this version, 4th edition, I guess, was made in 2006. I got this because, again, it's useful it's an introduction. I don't need to know everything about every nook and cranny, and I don't even have the intelligence to do that, or time. But I like how the first, 20 pages is an essay about the history. It actually has a very cool fold-out. I'll look at it real quick. Yeah, this one, look at this. So this is another thing I really, really want to make a video on, so I won't take too much time on this, and we'll flip through this whole book, so that'll take enough time as it is. But again, this is for me, this is something that we don't teach enough of. We always show the planets and stuff, and oftentimes you'll where's that thing? I have a box, but anyways, I have a puzzle box with the pictures of the planets on it that I also want to make a video doing, just, gradually doing a puzzle. I think that would be nice and relaxing. But the scale, so they always convey, roughly accurately the relative sizes of the planets, but they rarely convey the scale. Yeah, I guess this side's the best. This side's the best. They rarely convey the scale of distance between the planets. And here we have the sun with Earth to scale in the moon's orbit, and you can see, let's zoom in here. So we got the Earth right there. Come on. There we go. And the moon right there. Come on, focus. There we go, it's good enough, I guess. But, yeah, look how cool that is, because that gives us an accurate idea of just how far astronauts have to travel to get to the moon. This little pale blue dot right there is our entire planet. And we usually, we get images that depict the moon here, or here maybe. Not way out there. Not way 220,000 miles away. That's such a long, it was like a three-day journey. Going, I don't even know how fast, 30,000 miles an hour. Or no, I guess that's not right. I think maybe they were doing 20,000. Well, no, that's not even right. It took 3 days. Anyways, but again, it's showing the reality of the situation we're all in, how small we actually are. To me, that it helps us unify and recognize the similar position we're all in. You know, we're all mortal beings, but we're also on this same planet, you know, and we share a kinship that really oozes out of these pictures when you recognize that this huge thing is right there. These are the actual distances around the sun that our planets exist at. You can't even see it on the scale. If the sun is this tiny dot, Earth and the other planets, for that matter, aren't even registered. Don't even register. And then here is a more galactic and intergalactic scale, using a football field, an American football field. Let me set this aside real quick. In the United States, so let's see. Let's get the glare off this, make sure. The glare. We have, first of all, up here, let's zoom in. All the way at the goal line here, we have the sun as the size of a grapefruit, sitting right on the goal line, right on that white line, touchdown line. And then we have Mercury, Venus the size of a poppy seed. Earth, Mercury and Venus are, within the first 7 yards. We'll say meters, just in case, just to make everything, universal. And then we have Earth, a poppy seed resting on a quarter. The quarter represents the moon's orbit. Earth is sitting at, about 12 meters out. And Mars is just over 15 meters away from the sun. And then now, to convey the accurate distance, just how far away Jupiter is, we have just, let's say, 66 yards from the grapefruit. We have Jupiter. We have let's see, basically a 50-yard gap between Mars and Jupiter. And Jupiter's a raisin. That's what it is right there. A raisin. 66 yards from a grapefruit, if you can imagine that. So that's just incredible. And then we have about the 30 to 40 yard mark, we have cinnamon powder sprinkled, representing the asteroid belt between Mars and Jupiter. And then if that's not far enough for you, let's zoom out a little bit. Let's go ahead and give you the big wide view. There we go, that's a little better, I guess. There we go. look at this. So we got 2 football fields back to back. Saturn is way out there. Saturn is 120 yards away from the grapefruit, so double the distance that Jupiter is. Roughly double. Almost, relatively exactly double. That's such a massive difference in distance. I love this because it accurately portrays just how far out the planets really are. How separated, how far apart, rather. And far out from the sun, really. So, let's get this a little brighter. There we go. And then yeah, so the entire football field after that, after Saturn, is blank before we get to Uranus. And Neptune, I don't even think Neptune registers. Yeah, look at this. So Uranus is, again, it's very cool. Mathematically, there's a resonance with the planets. There's a resonance with the units of distance from the sun. Jupiter is, I think it's, I forget the exact ratio, but you can see Saturn. The distance from the sun of Saturn to Jupiter is a 2-to-1 ratio. From Uranus to Jupiter, it's roughly a 4-to-1 ratio, or 2-to-1 for Uranus to Saturn. And then Neptune is way, way out there. It says Pluto up here. It says Pluto is a quarter mile. About another 2 football fields beyond Uranus is where Pluto is. So I guess that's roughly where Neptune is as well. It's amazing. So, I don't know why they didn't even mention Neptune. That's weird. Beyond Uranus, Earth, Saturn. Yeah, weird. But anyways, and then down here, I guess maybe it's maybe we can get a better, less glare, but you can see here we have let's see. So a poppy seed on a pinhead at the 50-yard line. Poppy seed on a pinhead. So if we took our field and shrunk it down even further, so the sun would now be, maybe the size of a grape instead of a grapefruit, or maybe even smaller than that. But if instead of Pluto being a quarter mile out, 5 football fields or something, Pluto was 50 yards, so that's our entire solar system. A poppy seed on a pinhead at the 50-yard line equals the orbit of Pluto. Then the nearest star poppy seed on a pinhead equals Pluto. Oh, okay, never mind. I guess if the whole solar system itself was shrunk down to a pinhead, then the nearest star would be about the 40-yard line. So that would be, about 10 yards away, which is incredible. So if we shrunk 5 football fields down to the size of a pinhead, the nearest star, Alpha Centauri, would still be 30 feet away. 10 meters. And then, to continue onto the galaxies, the Milky Way would be roughly about 50 miles in diameter, which would be, the size of so our entire solar system is the size of a pinhead. Then our galaxy, our Milky Way galaxy, is about the size of a city. Just really let that sink in. Just the magnitude, the size of a 50-mile, that's a large city too. So, that'd be like 5 times, maybe 10 times as large as my city. And you just think, a pinhead is our entire galaxy. Maybe this right here in our Milky Way is 50 miles wide. And imagine there, hundreds of billions of stars within there. Just imagine how many other civilizations there might be, might have evolved in the last 15 billion years. Excuse me, I gotta take a drink real quick. Yeah, so again, we're going orders of magnitude. It's almost like orders of 10 beyond this. So the next galaxy was it? M31 is the Andromeda. That's 1,100 miles away from St. Louis to Salt Lake City. That's amazing. That distance in our entire solar system is the size of a pinhead, compared to 1,100 miles. That intergalactic journey would take some revolutionary technology for us to reach. So, anyways, we got through this book. We got 20 pages into this book. I mean, we really didn't even do that. I just jumped right to that chart, that little diagram, that image. But I guess there's really not much I can go through without, giving you a whole rundown on the cosmic landscape. But yeah, this book in general for me is just a very, useful source of information. A quick look up, and got a little wet towards the end. You could see it's crinkled up, but despite it being a little worse for wear, it's still for me really useful, and it's really cool just to browse through. So it's maybe I'll put some links to the Amazon or something like that. Because these books, if they're a little bit out of date, and again, I'm sure 95, 99% of the book is still very usefully accurate information. So we It's an easy way to... Oh, shit, I'm sorry. I just realized I didn't reset the camera. So we, for very cheap, or you can go to your library, but I like writing in my books, so, I just started reading the first couple pages of this book. I like highlighting and underlining. It doesn't, if that means I have to get a book that looks a little used, I'm okay with that. And, I think this book was maybe $4, maybe $6 with shipping or something. So, to me, that's well worth it. I actually paid $8 to get the original 1959 article by those guys I mentioned earlier. I think it was Giovanni Cocconi and Philip Morrison. They wrote a paper called Searching for Interstellar Communications in the journal Nature, a very prestigious journal that, again, makes you pay like $9 per article. I had to do that, so I couldn't access it. An article, 60 years old, I still had to pay $10 to access, but it was worth it. It was a neat little article, and breaking down why they think hydrogen is the best range of the electromagnetic spectrum to probe the universe for extraterrestrial communication for. So we got, the first... Yeah, I mean, this book is useful just for the background of what we know in the, brief little history of astronomy. Even gives you a little practical advice, like our Geography of the Heavens book did. And for looking at, stars in your backyard. And then we get into concepts of gravity. Here's a good little excerpt for the EM spectrum. Let's see. But yeah, anyways, I particularly wanted to spend so much time on that one little pullout because of just how useful it is for orienting our perspective in the world. Just how large the Earth seems to us, yet how small in the cosmos it actually is. How vast the distances are between the planets, let alone the stars, and let alone the galaxies. We have a lot left to explore. Here's electric and magnetic energy fluctuating on their separate axes. So yeah, this will be like a really useful little reference to look up. Here, like how they know the age of the Earth. I gotta look at this one because my dad's always very adamant that you can't really know that the Earth is more than 6,000 years old. So it's funny. No doubt a reason why I worshipped science as a young kid, just to spite my parents, as many teenagers might do. Okay, well, this is just laid out like a general textbook, as you guys can see. So, oh man, I hope it was still recording. but just wanted to, yeah, I was just happy to show you guys this, because who knows how long it is before I'm going to get done with this Drake equation script that I'm working on. But I've been learning a lot about astronomy, and I've just been excited to show you guys my books. We'll make a separate video showing you guys the other books I have. Surprisingly, Carl Sagan's Cosmos, the actual book called Cosmos, is a really useful book for my Drake equation. It has a whole chapter on SETI, and I didn't realize Carl Sagan was actually an integral part in forming the search, SETI being the Search for Extraterrestrial Intelligence community. So, even this book I didn't get a chance to get to, but we'll be doing a whole video. I'll be probably working out some rocket equations soon. This one's very cool. How he was a rocket engineer, you know, perhaps a Nazi. Kind of looks like a Nazi. Damn fascist. But he was a German scientist in World War II, and he came over and got very famous working for NASA and being integral in our Apollo space program. And this book is him explaining Space Frontier. Yeah, essentially the engineering in science that goes into NASA's Apollo space program. So this book is very cool, and it'll be a good groundwork for when I eventually get to doing a video about Elon Musk and SpaceX, because that is a whole story in itself. I feel like Elon Musk is he's just such a boon to humanity. The things he's achieving are inspiring so many people to take control of their lives and do something great and positive. Great and positive. So, I'll leave it there, guys. Thanks for watching. And again, seriously, thank you. I'm going to have to edit that intro out. It was way, way longer than I wanted it to be. But thank you, all my Patreon supporters, and everybody else that shows me love. It means a lot, and I don't say it enough. So, I just want you to know how grateful I really am. Hope you guys enjoyed this. Get some sleep and relax. And I'll see you soon. I'll try to be a little more consistent with the output of videos. Till then, though, take care. And get some sleep. Bye.